So before we talk about converting them to Python, let me go over some basic principles of coding and how coding works. So if you've done computer science, none of this stuff will be new. But that's okay. I'm also going to try to throw in some Python syntax things. In fact, I may throw in a few Python syntax things that if you don't know coding Python yet, you can kind of ignore it as we go. But here's the idea. Here's the idea with code. Okay? In code, you kind of have two main ideas, principles, or things that exist. I mean, actually, I may be able to use the tablet here. Let's see if it works. Nope. Okay, you have objects that have data attached to them, or just data. You can simplify this category to data. Okay. So you have data, or objects, and then you have actions that we generally call commands. You can also call them functions. Okay. So the idea here is that you have stuff, objects and data in the scene that you want to manipulate, and you manipulate them with these commands. That's the whole essence of code. You essentially have a bunch of commands that either create or update data. And this is the same way that you work in most any software like Maya. Okay, you're kind of doing the same thing, except you're doing it with an interface, not with typing code, right? So I have a command and I have like objects with data. So for example, I can say create a sphere. How do I open the controller? Thank you. Oops, I had the right button. Okay, so my first action or command was create a sphere. Okay, command was create a sphere. The result was a sphere. This is kind of my object with data attached to it. What data is attached to the sphere? You have like, yeah, you have how big it is. You have where it's at. You have all these numbers, and you're used to dealing with all these numbers already. Okay, and then what's my next action I want to do? I want to do this. Okay, so you have a command. And what commands do is, again, they manipulate or they update data. The data is kind of the sphere with its position, all that stuff, all the vertices, all that stuff. Okay, so I just ran a command, and I can see that it changed the data. I told it to move up by 3 point something, and it moved up by 3 point something, and now I have this kind of updated data. Okay, and then I can keep doing whatever I want to it. I can keep doing commands, scale it. Okay, the data changes. Move it again, the data changes. Move some vertices, the data changes. Okay, so it's all these kind of actions and with resulting changes to these objects and data. Okay. Code is the same way, but it's not always visualized. Okay, code is still manipulating data, but you can't always see it. Like, that's why we like to do this in Maya, because you can actually kind of see the results of what you're doing. But if you think about a bank statement, your computer has to store numbers, and hopefully it doesn't mess up with those numbers. It better not, otherwise there's going to be a lot of lawsuits and stuff going on. But it's keeping track of how much is in your checking account, how much is in your savings account, which when I was a student was negative, that sort of thing. And it's keeping all the track of this somewhere in the computer, and it can display it as a bank statement if it wants. Same thing here. The computer's actually kind of keeping track of. There's a sphere called pSphere1. It keeps track of all this stuff kind of under the hood, and then displays it in the interface for you to be able to visualize it. Okay. Questions about that? That's the basics of code. And then it just runs command, which changes something. Next command changes more. Next command changes more. Next command changes more. That's the essence of code. Unless I'm getting something wrong. So, anyone correct me if that's. So again, we're delving under the hood a little bit, which is good. That's what you want to do. Okay. So let me introduce Python. So we're going to go to the Python tab. Hang on. I'm just trying to make space here. Paste. Okay. I'm just getting rid of all that garbage up there. So here's Python. Python can do Python code, Mel code. They're all just a bunch of commands working on data. They just have a different syntax, different ways to type things out. Okay. And Python can do more stuff than Mel, and it's a little bit cleaner, just quite a bit cleaner. Okay. So we're gonna introduce you to Python, and then we're gonna get back to begin. How do you convert Mel to Python? So in Python, I can do stuff with just this. I can do stuff with just this editor without anything happening in here yet. Okay, like I can just print stuff. Like here I'm saying print nothing, even though you see two quotes. You'll learn what that is in a moment. But the idea is, I can say print 1. And again, it's kind of copying what I typed, and then it's doing it. And it just prints the number 1. Okay. I can say print. Let me actually open it with parentheses. I'm going to do it. Yeah, I'm going to do it this way. Okay. So I'm introducing you to your first Python command because I'm going to use it a lot. Okay. You have the print command. And the way that commands work in Mel is that you type the name of the command, space, and then all the inputs. With Python and most other languages, you type the name of the command, you open parentheses, you give it all the inputs, and then you do close parentheses. So how do you know if something is a command in Python? You'll see a word followed by parentheses with 0 or more things inside of there. I think if you say print and you don't give it any inputs, I think print still knows. Oh. Print's kind of an annoying command because it printed the parentheses. Print works a little bit different than like all other commands in Python, which is annoying. But whoops, print. Because it says, oh, I didn't see anything in the parentheses, so I'll just print the parentheses itself. Okay, forget that. That's not really supposed to happen. Okay, so if I put something in the parentheses, what the print command does is it says, if you give me something, I'll just spit it right back out to the screen. That's all I do. Okay, that may seem useless right now, but it's actually very useful later on. Okay, but it does let me show off kind of an idea. Well, I can use this as a calculator. That's kind of the first thing that it can do. I can say print 1 + 1. I hit say enter. It prints 2. So already I see that I can do some math with this, and then it'll print it out. Okay. Let me see. What if I just do 1 + 1? Okay. So before we get back to print, result 2. Let's talk about the calculator a little bit. Okay. There are 2 types of actions that you can do in code. One is, and they're related. One is a command where you type a word, or like polysphere or whatever the word is. You type a word and you give it inputs. That's a command, often called a function. You'll hear me say function. Function is just a word that takes inputs. and when you hit enter, it does something. It creates something or edits something or whatever. The other type of action that you can take is what's called an operator, like the plus sign here. It essentially says for an operator, you give it 2 inputs, and the 2 inputs are on either side of the operator. Now that's funny to formalize that because you've been doing that for years, but that's what an operator is. It's a symbol with 2 inputs on either side of it, and it does that operation. Okay, so I can do 1 plus 1. I can do 1 plus 3. I can do 1 plus 32, whatever, 32. I can do 3 times 1,000. Okay, result is 3,000. Pretty basic stuff. I can do 3 divided by 1,000. Okay, it says 0. We're gonna get back to that. Right, we're dealing with integers here. Okay, so all of a sudden we're running into something, but let's not forget that we have data here. Okay, so remember you have actions, you have data. The actions do something to the data. So what's the data in this 3 times 1,000? What values? Another way to think of data is values. What values is it dealing with? 3 and 1,000. The operation is the multiply. Okay, so you have an operate, you have an action, you have the operation that's multiplied. You have 2 pieces of data. Okay, trust me, this stuff gets more interesting. You gotta start kind of from the ground up, because all this stuff that I'm kind of talking about now, it builds on each other. So we're gonna talk operations, functions, all this stuff all the time. And so good to just kind of wrap your brain around that. So again, if you don't get it all clear right now, this is the stuff that you start asking questions about over, between now and Tuesday as you're working everything out. Okay? So you have 2 things of data, 3 and 1,000, and the computer says, "What do you want me to do with it?" Well, I said, I gave you this operation. I want you to multiply the 2. And then what's the resulting data or value?
3,000.
What's that?
3,000.
3,000. Okay, so you come up with some kind of. So again, programming is all about doing operations to data. You do it every day with your calculator or whatever you use, if you use a calculator anymore. Okay, so with data, I'm just going to type this here. Okay, you're dealing with this isn't Python code. This is just me typing. You're dealing now with something called data types, or there's different types of data, or there's different types of values. This idea will haunt you for the rest of your life. Okay, it doesn't really haunt you. You get it down and you're like, okay, that makes sense, and it becomes intuitive, and then you don't even think of it much anymore. Okay, but there are different types of data, and that's extremely important. And there are many different types of data. Okay. But let's start simple. What would you call this?
String.
It's not a string. If you're gonna be like super technical, what is that? Okay, it's what type of value is that? It's called a number. Yeah, and it's actually called a whole number, because there is no decimal there. In programming language code, I wish this was bigger, but it's called an integer. Okay. And you've heard that term before. Whole number, integer, same thing, but we call it an integer. Okay, what about this? 3.0. Okay, what would you call it if you don't call it double? If you think he's crazy for calling it a double, what's that? Okay, what if you call it a float? What if you think he's crazy for calling it a float? And what would your I don't know 3rd grade teacher call this? Okay, decimal, right? Decimal number. Okay, so in programming terms, we call that a float. In Python, it's actually float. They don't use doubles in Python. Even though they do, they just say float. Okay, so that is a float. This is an integer. So why in the world do we care? Like, that's kind of ridiculous, okay? 3 and 3.0, for all that we care, are the same number. Okay, well, the The computer cares because the computer does exactly what you tell it to do, and sometimes this distinction matters. And if you use the distinction incorrectly, the computer may think you're doing that. In fact, it will think you're doing that on purpose, and it'll do exactly what you tell it to. So, for example, if I do 3.0 divided by 1,000.0, what do I get? I get 0.003. If I take a decimal number or float, and I divide it by another float, the answer is going to be a float. Okay? If I take an integer, 3, and I divide it by another integer, 1,000, it says you're giving me two integers, you must want an integer as a result. So it gives you back an integer, or a whole number, 0.
So does it always just round it?
It has to. It has to round it because it has no idea that, in fact, it truncates it. It just removes the decimal completely. So it doesn't even round. It just says no decimal.
So it will always give 0 whenever you try to multiply or divide integers that don't make whole numbers?
Yeah, so if I do 22 divided by 7, does anyone know what that is?
Pi.
That's pi. And the reason people know this stuff is because they like shove this in your head a million times in like computer science and physics classes. That's what I'm trying to do too. So 22 divided by 7, that's pi. Okay, so the result is 3. It's actually 3.141 whatever, right? So, but the computer says, hey, you gave me two integers. That must mean you want an integer back. Okay. Why does it decide that? Well, some smart guy who wrote Python said, hey, I'm going to make the divide operator, this dash. The dash does a division. I'm going to make a divide operator that's a dash. Or is that a slash? What is that? Slash? Whatever it is. I'm going to make a divide operator. I'm going to make it the slash symbol. If they give me two integers on either side, then I'm going to give back an integer. Because I assume they want an integer back. That's just whoever wrote Python made it do. You didn't have to do that, but he's just like, I'm trying to be consistent. And that's what most programming languages do. Try to be consistent. So now it matters big time. This is why rockets carrying billion-dollar satellites blow up. Because someone does that instead of putting decimals in the decimal. So that's why data types matter, because you don't want to blow up any rockets. That's what you probably won't. So.
Does anything crazy happen if you have like a float divided by an integer?
Yeah. So now the poor man who programmed up Python had to say, well, now they can give me anything. They can give me any type of data. They could give me floats or integers. So what if they give me let me find a good. What if they give me a float on one side and an integer on the other side? What should I do with that? Well, okay, that's what it does. It says, hey, if you gave me a float and an integer, I'll give you back a float. If you give me an integer and a float, I will give you back a float. If you give me an integer and an integer, I will give you back an integer. It says, you apparently do not want those decimal numbers, so that's what I'll give you. I'll just give you an integer. Sometimes that's actually useful, right?
Can you just do the point, or do you have to put 0 on it?
Good question, actually. That's an I don't know. If you do 30, yeah, 30 point says, hey, this is a decimal. Good question. Yeah, so that's data types. Okay, there are lots of data types, but for now, I'm just going to introduce you to integers, floats, strings, and in a little bit lists. So, okay, what if I do? Okay, there's another data type called a string. This is a string. What is a string in English? It's just a character. They call it a string because it's a string of characters. Okay. So the way that I tell the programming language that something that I'm giving it, the value that I'm giving it is a string, is I put an open quote, I type the string that I want or the characters I want, and then I put close quotes. Okay. So the quotes actually are not part of the string itself. Let's see what it does if I say Bob. So it says result Bob, no quotes around it. So again, this is, if I just type Bob, it's working like the print statement. It says, oh, what are you doing? Okay, I'll just spit back out when you type. Okay. But the idea is that computer programs can work with data called strings. Boy, what kind of things would you want to do with a string? You do stuff with them all the time. Because Ew. Those are the kind of jokes I'm supposed to throw out. You guys aren't allowed to throw out terrible puns. So no, that's true. No. That's actually a very legitimate answer, because what would any normal person do with a string? They would go fly a kite. So, absolutely. So, but when you get in the coding world, you have strings, and these strings are gonna be words and stuff like that. So, for example, if a program was asking you, which object do you want me to select? You're going to give it the name of the object. How do you give it a name of an object? As a string. Okay. In Mel, strings actually don't have quotes around them. That's why you haven't seen the quotes before. In Python, they have quotes around them, just kind of for cleanliness, to say this is a string and not supposed to be something else. Okay. So, yeah, quotes are a string. So let's go back to our division operator. So what is this then? This is, yeah.
So when you did the print and you did the parentheses, you were creating a bunch of strings that had nothing in them?
Yes. That's kind of a weird thing, but I think it was, oh, let me say no, not quite.
So wait, the string is the thing inside the parentheses, right?
Yes. So if I can say, I can have a string as an input.
And does it always have to be alphabetical things, alphabetical?
Alphanumeric. So it can be a period, it can be
So it can be anything.
anything.
But it
Right.
just has to be in the parentheses.
Yes,
Or
in the quote. Why is that? Because if I say print 3, yeah, it'll print 3. So let me show the distinguishment. It's still extremely important for it to distinguish a string, okay? So this is no longer the number 3. This is the character 3, okay? So if I say 3 divided by 1,000, it's going to say, what the heck are you trying to do? You're just taking it, all it sees is you're giving it a character, some symbol, which looks like the number 3, and it says, you gave me this symbol, or this character, and you're trying to divide it by 1,000? Like, that doesn't make any sense, at least in this planet, at least that I can think of. Unless you chopped up that 3 into 1,000 pieces and had a bunch of 1,000 pieces of a puzzle that you put together in a 3. I don't know. It's like it's freaking out. Okay, to say, hey, you just gave me a string is what this means, and you gave me an integer, and I don't. In the division operator, it's like I can only do so much for you, right? I can do stuff for you if you give me numbers, but if you're gonna insist on stuff like that, then I'm gonna complain. Okay, so I'm actually gonna show you something else though that kind of distinguishes different data types. And again, we're talking about data, and that there's different types of data. Yeah.
But if you wanted like the number or whatever 3 divided by 1,000 is, like, would you put it as like an integer inside like a string? You couldn't do that, or not?
Like this.
Oh yeah, with a decimal after.
This. So if I do this, so let's start with this. If I say divide, if I just say that, it's like invalid syntax. That means invalid syntax. You'll love this error after a while because you'll see it quite a bit. Invalid syntax means you just gave me an operator. It means you did something wrong with the syntax, right? Some of you have seen this already because you didn't have semicolons in the mel. What it says is you gave me an action, but you didn't give me any values to do that action too. You gave me an operator, but there's nothing to do stuff with that operator, right? So now it's like, yeah, 3 divided 1,000. And it's like, okay, I can do something with that, right? What if I do this? Now it's no longer the division operator. It's just the slash character that I'm giving it, okay? It can understand that because it says, oh, you gave me this a character, I'll spit you back out that character. Okay. That's just how Python handles me just giving it a string. It says, okay, I'll spit it right back out to you. Okay. Tell me if there's any major, yeah, raise your hand if there's like any major like weird holes I'm missing in the conversation. Okay. So does that make sense? If I just give it the dash, Python says that's a division operator. If I give it the dash in quotes, it says, oh, I see quotes, so you're just giving me a character. You're just giving me a symbol. And I will spit that symbol back out at you. Okay? So so let's do 3 times, I won't do 1,000, 3 times 10. It says, so the times operator is an asterisk. That's how you do multiplication in code. So 3 times 10, it says you gave me a multiplication operator. If you give me an operator, I need 2 values on either side. Okay, you give me 2 integers, great. I can take those 2 integers, I'll multiply them together, and an integer times an integer is an integer, so it gives me 30. Right. Okay. So what if I do this? Then this is kind of 3 times 10. Okay, it says take a character, multiply it by 10. Will it freak out? It actually, and again, this is because this is what the guy who wrote Python decided to make this operator do. It says, I'm going to try to handle as many different types of data as I can. Now with division, it just doesn't make any sense, so I'm not going to try to handle a string and an integer in the same sentence there.
Is that considered a for loop or something?
Not exactly. It's related. Under the probably an assembly code is for loop, but yeah. So essentially it just says, okay, if they give me a string and they give me an integer, hey, I think I can do something with that. I'll just take that string and multiply it that many times. Just literally multiplying. It's like rabbits, right? It's multiplying this 3 a bunch of times because it says you gave me a character and you gave me a number to multiply it by, and I will do it, right?
So it just put 10 threes.
Yeah. So there's.
Does it work in reverse?
Oh,
Okay, that's a good question. Okay. So what if I do it in reverse? Okay, so this still can handle it, yeah.
Can you do multiple, like, can you do times 3 divided by 2?
3 times 2 times, oops, times, wow. Okay, now it's like, whoa. Right. Okay, so I should be able to do a bunch of numbers in a row, right? It can handle that, but yeah. So again, this is just the Python guy said, this is how I want the multiply operator to work. And okay, but data types matter. Like, so there are different types of values you have. It matters big time because it says, are you giving me just characters, or are you actually giving me a number that I can do stuff to? Okay. And the inputs of an operator, what inputs can I give a multiply? What inputs can I give a divide? All depends on the person who wrote the multiply and the person who wrote the divide. So this is an important thing about commands or functions or operators. Is that there are many different kind of commands and operators, but how they behave, the inputs that you give them, all depends on the person who wrote that operator, or the person who wrote that command. He or she decided how it's going to behave and what you're allowed to give it as input. Okay, so we're kind of trying to push the boundary. What can I give these things as input? What can they behave on? When I do give them this input, how does it behave? Questions about like data types. Data types are what strings are. Okay.
does print do? What is that? Is that a command?
Okay, print is a command or function. Remember, there's kind of there's two types of commands you can do. You can do an operator, you can do a function. Function is where you give it a word, open, close parentheses, and inside that parentheses is the input. How many inputs? What inputs can this command take? It just depends on whoever wrote this command, what they told it to do. So anytime you learn a command, you need to learn what is the command name, what does it do, and also, in order to do that, what input do I have to give it? Because each command takes different input types. Well, the print command, it essentially says, give me data, and I'll spit it back out. Okay? So again, I can say, print says, give me one input, the thing you want me to print, run it, and it'll print it. Okay, so it printed Bob. I give it a number, and it prints it. Here's another thing about commands. Oh yeah, go ahead.
Can a function take an operation?
Sort of, yes, in a way. Okay, here's generally not. It doesn't actually take the operation as input. I'll just say that for now. Some people get insane and do stuff like that, but for all our intents and purposes, I don't like to. No. So, okay. So let's say I do this. Okay. Here's another critical thing about commands. If I kind of have one type of command or an operation inside it as input to another type of command, just like in math, there's order of operations in coding. So in math, if I see like a parentheses, what does that mean?
To go to that first.
Do this stuff first, okay? So what it's going to do, print says, hey, I need some input. But before I actually give it the input, it looks at the input thing and says, whoa, wait, there's an operator there. Before I actually pass that input, they call it passing it in. Before I give it that input, I have to resolve this operation right here. Okay. So first it's going to do 3 plus 10.5, which is 13.5. It says, okay, now I have a number, because print needs a number or a string or something like that. So once I've resolved it, once I did the addition first, I get 13.5. The print says, the computer now says, oh, okay, that's resolved. I have 13.5. I'm going to pass 13.5 to the print command. Boom, there it is. By the way, if I'm saying, like, hopefully this is helping explanatory. If I'm saying obvious stuff to you, like say, hey, you're saying obvious stuff, because, like, I had to break it down to this level when I was learning it, and so sometimes I kind of work in that line, so I feel like, whoa, that's, yeah, obvious, let me know, but, so I'm not trying to, like, yeah, I'm not trying to, like, oversimplify. It's just, that's kind of how I understood it. So, so does that make sense? Code kind of has this order of operations. It's kind of this hierarchical thing. It says, oh, you're giving me an operation and a command. Let me do this first. Compute it. Okay, I have a value. Now that I have a value, I can give that value as input to the
So
command.
are operations always in parentheses?
They don't have to be. If they're just by themselves,
Okay.
okay, they're okay. But if I have the move command, like to move a sphere or something, and I want to tell it how far to move it, so I can tell it to move something. This could be like, maybe I say, you can do stuff like that, where it says, oh, I have one value. I want to take two values of two other objects, add those two things together, and that determines how far this third object moves, or something like that. So you can do some pretty crazy stuff. So in this case, you have a command. So what I'm saying is, you could do that operation by itself, but it's more useful to say, I can do an operation and then give that as input to another command that's going to use that as to do whatever I want to achieve with it. Okay. So
Is move a Python function, or is it like specific to the library of Maya?
it's specific to the library of Maya, and I'm going to show you how to do that in a second. So you actually wouldn't say just move by itself. Okay. So, but I want you to have some sense of what a data type is. And data, again, is synonymous to value. There's different types of values that you do stuff to. And you see that in Maya, again, with the sphere. Your translation, it's just a bunch of values. It's just a bunch of data. And those data are floats. Okay, the move, yeah. The move data, the X, Y, Z, those are floats. They tell you where in space is positioned. Yeah.
So why don't you need a semicolon after? What you
So a lot of languages use semicolons. Python's clean enough the way they arrange things that you don't need semicolons. So that's a beautiful thing if you learn to code. You don't have to keep worrying about leaving out semicolons because it happens all the time.
So the equivalent of a semicolon in Python would just be a line break?
Yeah, new line. Yep. So every time you have it, so if I say print 3, print Bob.
Oh, with Mel, you have to have a thingy.
What did I do?
So
Tent. Okay. So and again, it just does the commands in order. Oh, you want me to print 3? I'll print 3. Oh, you want me to print Bob now? I'll print Bob. There, program done. Pretty inane and useless, but yeah.
So I guess we can follow up with that. Does that mean then that all of your functions have to be on a single line?
No. You can do one function per line. You just do them in the order. It's like the little seesaw code that you built. It's just one function after another function.
If you say like print, open parentheses, enter, Bob,
Oh,
enter, close parentheses.
sorry. If you do what? Oh, like this.
Yeah, and then that's it.
Yeah, it's very sensitive to new lines. Wow, that works. It's trying to be helpful.
Sorry.
So generally in code, so not to confuse you guys, generally yes, you want to keep it all on one line. For each command, just keep that on one line. And then for the next command, put it on the new line. Yeah.
Okay.
And so if you do need commands as input, like that, then it'll all kind of line up on the same line.
Yeah.
Otherwise, yeah, it'll.
Do you need a space in between each parentheses?
Oh no, sorry. That is my habit. No, you're perfectly internally. So internally, you can kind of use as many spaces as you want. Like in here, it matters, right? So inside of quotes as a string, the space is actually a character, its own character. So it says print the character 1, then print the character space, then print the character 3, right? So it just treats us all as characters. But otherwise, yeah, their spaces matter. Otherwise, spaces don't matter that much. You'll find that spaces do matter for indentations, which we won't use today, but we do use them. Yeah.
So are strings what we would use to identify objects and assets within our scene?
Yes. So if you want to say move psphere 1, you would tell it psphere 1 in quotes. Yeah. Absolutely.
So what's like the difference between a variable and a string? So the objects aren't variables, they're strings.
Variables store data or values. So it could store a string.
So you wouldn't call it the object, it's the variable.
Correct. The object is stored inside of the variable, but it's not the variable itself. Yeah. And we'll get to that. Variables are kind of the next thing. Let me skip over, stand up for a minute, and then we're going to cover 2 more things. One is how to convert your Mel to Python, and then 2 is how to use variables. Hopefully I can cover it in enough time.
You told us to tell you if it was
What,
if we had to know this stuff.
Expectedly.
Like, if I'm going too slow, just like
Oh, yes.
yes, you're going too slow.
Those were you, Jared.
Okay.
No, trust me. Like when I was learning this stuff, oh my goodness, I was like, until like, this is how I had
No, actually, it's kind of helpful because I feel like I might need to use this for people working on other things. Like if I want to explain to somebody how to use Unreal and put their art assets in Unreal, I have to be like, okay, let's talk about computing design.
Yeah, and how they did that for Brandon.
Right.
Yeah, I had to go to the same thing.
So I was wondering about the lines, multiple lines. Because like for example, if you have nested a bunch of stuff, and it's later to break it onto multiple lines.
Yes. In Python, you have to break rules. If you have a for loop, and then inside the for loop, you want to tell it what things to do. Those each have to. You do the for loop line, and then you do each of the things that the for loop is supposed to do as new lines. So every command has to be a line.
Oh.
Unless apparently you just do it at one single
on my mission, like
Okay.
For loops are interesting because have you done code?
So I've taken 124, 142.
So you use open bracket, close bracket for loop, right?
Yeah,
Or
it's
brace.
been a few years.
Yeah. So instead of using braces, because you could do for and then open brace and then a bunch of commands, semicolon, separated, and then close brace, in all on the same line in C if you want to. And Python forces you to say for new line, and then you actually have to indent. And then indentation means anything that's indented is inside the for loop. And once I unindent again, I'm outside of the for loop. That's the next line of code. So using new lines and indentation, you'll be going over Tuesday.
Okay.
And that's something we can. I can definitely show you a little trick.
Okay.
All right, let's go back in. Oh,
One of the smaller things. I was playing around in high school. It's programming Blender and enjoyed it. So I wanted to do school that
And Seth, I noticed one of the things in my presentation,
pretty easy to
like how many lines per segment.
sit down and play around on the computer
You have to
for
look at my example, but
hours without.
that was one of the best things that you showed us.
Oh, really?
Between 2014 and like 14.
Like in the code?
Yeah.
Oh, let me look at that one. Okay.
Yeah. Like I don't really get like frustrated with the computer.
Let's expand the fire hose just a little bit. Lighter hose here. Just a little bit. But again, the best way to learn is to do this and do this and do this and ask questions and say first, before you just try to get the assignment done, don't just try to get the assignment done. Otherwise you just flounder. Try first to say, okay, talk about some of these principles. I'm going to mess around with code and try to understand these first. Now that I understand them and I've asked questions, now I can dig in and do more stuff because it's starting to make sense. Okay, so meld to Python. So now let's get back to pretty pictures and that sort of thing. So if I want to create, if I create a sphere and then I move it. Let me do this copy paste thing. I copy that? Copy, paste. Okay. Here is my mel code. If I run it in here, this is another gotcha. If you get mel and you're running in a Python tab, it will not like it. It'll say invalid syntax, and that's about as good as an error as you get. Because it's like, whoa, I don't see any open parentheses, I don't see any stuff that I need to see. Okay, so this is the most exciting part of this assignment is if I want to convert this to Python, the first thing is that just in Python, just in regular old Python, there is no polysphere command. Well, Python does this really nice thing where it says anybody can make up a new set of commands, and package it up, and make it available to anyone else. So the people who made Maya said, okay, we'll make a bunch of Python commands, the map to ML commands, like there's a polysphere command, a move command, etc. We're going to take those and we're going to package them up inside of a package that in Python they call a module. And how do I access this module? If I say import maya.cmds, it's essentially just a word. If I say import, there's out there in Maya a Python package or module that says this contains all the Maya commands inside of this package, and now that you've imported it, you can use it. So I've essentially imported all these additional Python commands that they made available. So you'll always want this in there. And then from there, I'm going to say maya.cmds.whatever. Okay. So what it's saying is look inside the maya.commands module. If I put a dot, this dot means look inside this module. Look for the polysphere command. Now it'll be able to find that command.
Is a module just like a library then?
Yeah, it's like a library. It's like a library of commands.
Did you just copy Maya.that to the top and just brought it down?
Yeah.
Okay.
So I said import it first, otherwise it won't know what Maya.commands is. So I said import Maya.commands. And it has to be this. It's case sensitive everything. Some guy named George or something, I don't know, he said we're going to make something called Maya.commands, and that's what they called it, and it's case sensitive and everything. You have to import that exact thing.
So after importing it, do you still have to type in maya.cmds before you use any commands for Maya?
Yes. There is kind of a trick you could play to say, okay, I'm so you don't get RSI or something. There's this as thing that says import maya.commands, but call it MC instead. So you can kind of rename it. I don't know why as doesn't turn yellow. It should. When something turns yellow, that means it's a special word set aside in Python to do something very special. It's like it's just a key word. Okay. So there's only like 20 or 30 keywords. They say these are words that we set aside for very, very specific purposes. One of them is import. You say import, and then you give it the name of a library or a module. It'll import that module. So it's kind of like a command, but just something very special. It kind of breaks the rule a little bit. But that's what you have to type. Import maya.commands as whatever. And then you still need to do whatever dot polysphere mc.move. The other thing is that if Python did have a move command, at least you're saying it doesn't, but what if Python did have a move command? Because Python does come with some default commands. If Python had a command called move already, and I said import all these Maya commands, and it just brought in move, it would completely overwrite the old move, Python's move, and that could be a bad thing. So you're saying, I want to grab the move that belongs to that library. So this is just good practice. So I'm gonna bring in this module, a bunch of new commands, and I'm gonna grab commands from that module. So that's what that does. So that's the first thing you do to convert. Okay. Second thing is a command. You don't need a semicolon. You need parentheses. Again, open close parentheses, inputs. Okay, so anything in this command, you need to open parentheses and then close parentheses. Again, you don't need those spaces. You don't have to have them. Now is where it gets exciting. exciting is my word for it. Yeah, you have to be a little on your toes, I guess. Okay, so yesterday or Tuesday, I kind of briefly mentioned there's something commands have. There's a special type of input called options. Options are this thing that has a dash. Okay, so this dash R with the input of 1, SX with the input of 20, SY of 20, and so forth. These are options. Okay. So if you see a dash something that says we're doing this option thing. In Mel, they list out all the options first, and then if there's any other arguments or inputs, they put them last. So in the move command, the dash R is an option, and then the next 3 numbers are required inputs called arguments. So options are inputs that are optional. Arguments are inputs that are necessary. And how do you know? You just learn the command. You look in the help or you ask or whatever. Okay. So by looking at the move command, I know that it is required to take 3 numbers and then options. And so you kind of have to swap them. Because in Python, the arguments go first and the options go last. Okay. In this polysphere command, these are all options. Okay. Each option has its own little input. That's an option, that's an option, that's an option. Okay. So first you want to swap the order of your arguments and your options. And then finally, every single input has to be separated by a comma. And I'm going to try to put this online if you feel like filtering through this video. I'm recording it, crossing my fingers. And then you can kind of look this back up at the end. Oops, I already did the close parentheses. So I separate every input with comma. Okay. Comma, comma, comma. So again, arguments are required inputs. Options are non-required inputs. Okay, and generally you know it's an option because it has, in Mel at least, because it has a dash. Okay, in Python, arguments, for arguments you just put the value. For options you don't use a dash, you have to use it equals. So you know it's an option if it says name equals something, some value. So SY equals 20.
And you have to swap them out with equals?
Yes.
Okay.
So we don't need to, we get rid of the dashes and then we add the equals.
Yes. Okay. So here I'm going to I skipped that one on purpose. Here I'm going to throw this at you. You're going to mess around with it, get to know it better, and then Joe's going to review it one more time come Tuesday. Okay. This is also where data types kind of matter. So this is easy. Oh, it's a number. In Python, a number, you just give it the number and it says, oh, that's a number. It says, oh, that's an integer because you gave me a numerical value without quotes on it. That's a number, that's a number, that's a number. 3 numbers. We're kind of getting fuzzy there. That's a number, that's a number. Okay. With the 3 numbers, I'm just going to give this, take this by faith a little bit for starters, and then once you start struggling with it, it'll matter more. If you see 3 numbers after an option, before the next option comes about, what you need to do is put these brackets around the 3 numbers.
What do those 3 numbers represent again?
This is saying what axis do you want it to have? We're saying I want it to have its axis, its up axis is 0, 1, 0, which is up in the y direction. So it's saying give me a up axis. Remember how yours was like upside? Was it yours that was upside down? Yeah, yours was upside down. That's because yours axis was 0, negative 1, 0. And for some reason it was defaulting to that. But yeah, so it says give it an axis where it's 0, 1, 0. So if you see an option that has 3 numbers after it, you have to put brackets, or however many numbers, you have to put brackets around the number, comma separated. Okay. So this is an input, this is an input, this is an input, that's an input, that's an input, that's an input. Those brackets just say kind of package these 3 values together as an XYZ. Pass it in. So we have one last problem here with this move. R. There is no value that, like if it said R1, I could say R equals 1. Fabulous. Okay. This is why Mel is kind of confusing, because there's all these dashes and numbers floating around. Which ones are arguments? Which ones are options? I don't know. Okay, so Python makes that a little more clear, a little cleaner. Oh, I know it's an option because it has an equal sign. Option, 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 option. I know this is an argument because it's by itself. It's by itself. It's just a single value. Value, value, value. Now I see this dash thing with no value following it. If you have an option by itself, you just have to say equals true with a capital T. It is case sensitive. That means I want the R option on. Make it true.
You can say like equals 0 or something.
I think you say R equals 1.
Yeah.
A 1 is the same true. So it's good generally to just say true.
What is R called again?
What's that, R?
Yeah, is it an argument?
This is an option.
That's an option.
Because the arguments, again, are just the value. And then the options are some characters equals something. So notice that there's no quotes around like AX or CUV or whatever. So it doesn't think it's a string. It knows it's an option. Yeah.
I'm sorry, I'm a little slow on the uptake. What are options used for?
Okay. Options are to create a sphere. If I wanted to do this command by itself, if I just did this, if I said don't give this command any inputs, I can actually do this. So you're essentially saying run the polysphere command, but don't give it any inputs. Some commands can actually work without an input. This command, it says, hey, if you just say polysphere, I'm going to guess that you want a sphere of size 1 that's created at the origin. If you want that any differently, you're going to have to tell me with the options. So option means it's an input that you can optionally pass into the command to tell it how to behave differently than the default. Okay. So some commands will say, hey, I have just a default behavior. Hey, if you say polysphere, I'll just do that default behavior. If you want it any different, go back to here. Because like I could say, because again, I can say, make that axis z, make this negative. Oops, I need to import the module. Well, it didn't. Okay, yeah, of course my examples don't work, but that's yeah, that's okay for now. So generally, if I want the scale, like the radius, to be 3, I say I don't want you to do the default behavior. I want to have this radius of 3. I can actually leave a lot of these options out and just say, hey, I want you to do the default, except I want the radius to be 3. And R is a special word that specifically belongs to this command. Whoever wrote the command made a bunch of options that have a specific letter for each option. Okay. So R in polysphere means something different than R in the move command. Okay. So you're like, oh, okay. You see there's already kind of all this stuff you can start taking in. The first thing you just want to say is, okay, I can convert this over to Python. Okay, now that I've converted to Python, start reviewing, okay, wait, why is there an R here and an R here? Do they mean different things? Well, that's because whoever wrote the move command made R mean one thing. Whoever wrote the polysphere command made R mean a different thing. And you'll start to ask these questions, you'll start to understand more about what that is. So, but yeah, as an intro. So yes, please ask questions about these. That's why you need a. That's why between now and Tuesday, you know, you can spend 10 to 12 hours on this, just messing around with your seesaw, converting it over, trying new things with the seesaw, and just nailing down these principles so that as we kind of build on top of some of these, you've already asked some of these questions, kind of internalize some of it. Okay. And again, trust me, this does get more interesting places once you really kind of nail down some of these basics. Okay. Here's another thing that's extremely important for your assignment, because in your assignment, you're going to have to create a polysphere. You're going to have to create a seesaw. And maybe you create an object, and then you group it, and it calls it group 1, and then you say move group 1 over here. Okay? And so you have a seesaw that you grouped, you called it group 1, it moved the group 1 over. Now you say, I want to run that code again. Create a seesaw, and then move group 1 over here again. But what's going to happen when it creates the new group? There's already a group 1 in the scene. What does Maya do?
It's going to move that group 1.
What does it do first? What does it call the new group? Group 2. The way Maya works is it says, if you're trying to create a group, I'll try to call it group 1, but if group 1 exists, I'll call it group 2. So if you say create a new group, so it creates a new group, it calls it group 2, now you say move group 1, what's going to happen? That first one's going to move again. But the new one, no, you're like, no, I want the new one to move. Okay. Now we're going to get into variables, and we're going to go over variables again on Tuesday. But you want to already kind of start asking questions, and then the help books and stuff, maybe on the help site, look up what's a variable, because they'll explain it to you nicely as well. Okay. Here's where something comes in called variables. Okay, so there's something very important about commands that I've been ignoring. So what do we know about commands? Commands do something to data or objects. They do something, and what do they require? Generally, inputs. Okay, 0 or more inputs is actually what they require, but it just depends on the command. Like move says, hey, I need at least 3 inputs. Otherwise, I don't know where to move it to. Okay, so commands, they do something and they have inputs. Commands also have outputs. Okay? They spit out data too. Not every command has to spit out data, but some of them do. And now, here's an important thing that we're dealing with. That again, this is practice working with us and ask questions. Because this is a question I know is going to come up. Is that when you do the polysphere command, its action is to create the sphere. But the sphere is not the output of that command. Because when we talk outputs, we kind of have Python land under the hood, and we have Maya land. In Python land, Python can talk to Maya. So you run the polysphere command, and it says, oh, my job is to create a sphere in Maya. So the computer, it runs the polysphere command. It creates the polysphere in Maya. That's what it does. That's its action. But then its output is actually a string of characters that says, here's the name of the object I just created. So in Python land, it spits out an output that's just the name of what I just created. But the action is to create it in Maya. Does that make sense? That's an important distinguishment. What it does is create something in Maya, but what it outputs is something that's still in Python. It's just this. It says here, I'm going to spit out the name of the object. Well, here you can actually see it spitting it out. It's not quite a string. But sometimes it can spit it out. It'll spit it out. It'll say, here's the output. Here's the name of the object I just created. And if there's nothing to store that value, then it spits it out and it's gone into the ether or wherever it goes. So now I'm going to introduce you finally to something called variables. in 5 minutes of variables, and then we'll review as you're working on it on Tuesday. What a variable is it's a characters. It's a thing of characters that you make up. I'm just gonna say sphere name. I'm just making this up. You just type some string of letters without quotes around it. If you put quotes around it, Python says that's a string. If you don't put quotes around it, Maya says that's a variable. That's a variable. What is a variable? A variable is just a label that stores a value. So if I use that label later, it's going to go look up that stored value. Okay. This is the syntax for Python for using variables. You say variable, space, equal sign. I actually don't know if you need the space, but anyway, variable, equal sign, and then your command, your function. Okay. What is order of operations here? It runs the command first, so it does right side first. Okay. It may not seem like it makes sense, but that's what it does. It says if I see an equal sign, I'm first going to do everything on the right side of that equal sign. You're right. And then once I'm done with that, if that spits out any output values, I'm going to store that in the computer and I'm going to label it with sphere name. Okay. So this is not a mathematical variable. Mathematical variable says y equals x plus 1. A mathematical variable is storing like an equation or something. Variables in code are not storing an equation. They're just saying, I'm going to take whatever was spit out here, and I'm going to store it in the computer and label it. Yeah?
So this looks like a grouping or a filing system where we can pull it back if we need it.
Yes. Yeah, file away for later. Here's the label we gave it. Go look up. If you look up this one, then I'm going to go get that value. That's exactly it. Filing system. Perfect. Is there another question?
So a variable is only a variable if it has an equal sign, right?
Yes. So if you have some name equals this, it'll store the output of that. Okay.
Is that just stored within this file, this sort of whatever? Like how long is it stored?
It's stored forever and ever until you store something different in that variable. Because you can store something. Okay, so here's another thing you can do with variables. You can say sphere name equals 3. Okay. So it stores whatever the result of this is. It's still storing that. It's still storing that. Oh, I just completely overrode that. I stored a 3 and I labeled it with sphere name, and now what was stored before is completely lost. It also goes into the ether or wherever, or no.
So does that mean the character with the numerical value of 3 has become the name?
Yes.
Your name,
So now
when you use it to like add something like 3 plus 2, it will like say.
Yeah, so now I say print sphere name plus 5. Let me just run that code. It's going to store the value 3 under sphere name. So it says, hey, view sphere name later. I'm going to go grab that value that I'm labeled, that I've set the label on. So it was able to do that because it went in, because order of operations, it first says, before it does the addition, it says, oh, you gave me a variable. First, I'm going to go grab the values that are stored first. And then, okay, I grabbed 3. Ah, that's storing 3. So I'm not going to add sphere name plus 5. I'm going to add 3 plus 5 because that's what sphere name is storing. 3 plus 5 is 8. Done. That's the order. Yeah.
Well, if there were 3 in your code and you changed that, would it then not work? Because it's like what's your name?
Sorry, if what happened?
Like if you had a 3 in the lines before, and then you said sphere name equals 3, would it then change those 3's to sphere name?
The ones above.
No, so it's kind of the opposite. It's actually not. So you can use 3, like you mean if you use it here or something like that?
Yeah.
Yeah, you can still use the number 3. In a way, the computer has no idea that they're related, because it said I can use the move. When I say move and you give me 3, I'll just move it 3. if it sees the variable, and then you're saying store 3 in this variable, so just store 3 away and label it sphere name. I can still use 3 later on. That label is still storing 3, and if you never use it again, who cares? It's just I'm storing 3, but you can still use the number 3, and it doesn't even know that variable is storing 3 until you actually use the variable. And that says, oh, go look up what it's storing. And it finds it. Yeah.
Do you have to call it sphere name, or can you call it
No. Oops. What is that? You can call it, as long as it's letters, you can call it ASDF. And then now ASDF is storing that. And actually, if I got rid of this, sphere name no longer exists because now I'm using ASDF.
You can use like underscores and everything as long as there's not spaces, right?
Right. You can't have spaces. Has to start with a letter. And generally, I just use letters. They can be capital, uncapital. They're usually, yeah. Okay. One other thing I'm gonna. Wow. Oh yeah. Go ahead.
Just out of curiosity, on line 3 where you said that variable equals the value of polysphere, well, like how would you use that sort of assignment in practice? Like if you like call that variable again, would it create a sphere or?
No. So that's where it's not storing the command. So when you say mc.polysphere, polysphere, this action, this command, this function, it creates a sphere, and then spits out the name of the sphere. The name of the sphere is not going to do anything. It's just a string of values that just says, oh, you wanted me to store the name of it, but the actual action is done. It's through. Does that answer your question, or is that?
Yeah, I was just wondering what polysphere returns.
Yeah, return. Okay, so here's what it returns. I'm going to go a little longer. If you need to go, go, because the time's up. I'm going to talk for about 5 or 10 more minutes about it. It actually returns a value, a data type called a list. But I'm recording it, so hopefully the recording works out. But I'm going to kind of put this on the record here. Let me introduce you to one thing called a list. Let me ignore this. So in Python, to ignore a line, you put a pound sign. It's different than mount. Pound sign means ignore it. Okay, so it runs this line of code, which is ignore. Ignore, 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 ignore. Okay, line 6. So again, I can just store a value. That's a variable, Bob equals 3. I can just store a value, and now anytime it sees Bob again, it says, oh, that's just a label. I'm supposed to go look up what's stored in that label. Oh, 3 is stored there. It'll print 3. Okay. That's the data type. We can do 3.0. I can store any data type. Bob equals that string. It's just storing the letters, the characters ASDF. Yeah.
So you don't have to define the type of variable that it is, because it'll be able to tell.
Correct.
The input.
In Python, you don't tell it what kind of variable it is. It automatically knows. It figures it out. Yeah.
Okay.
So that's a big Python thing. You don't have to declare types.
Change data types.
Yep. I mean, it can change data types. Yeah. So I can say Bob equals that, and then Bob equals 3. This is an important one because Bob, remember, this is where it's important that it does it in order. It says store the letters ASDF under the label Bob, in variable Bob. Now store 3 in the label Bob. What happens to ASDF?
3.
It's erased because I said use that label to label something different. So now ASDF is gone. Then it runs line 8, which is do nothing. Then it runs print Bob. What is it going to print? 3. Because Bob, the label Bob, the variable Bob is currently storing 3. Okay. So order of operations is important. Okay. Here's another. Remember, I can call this label. I can call this whatever I want. If I call it sphere name, the computer doesn't care less. It doesn't know that it's called sphere name. It just sees that as a label. It's a label. Okay. I just, as a programmer, I label it something useful because so that I can read the code later. Okay. So something you want to do with this is there's one other thing that's called a list. What it is it's 2 brackets, with comma separated values.
Like an array or a vector.
It's an array. And so in Python, what in the language C++, what they call arrays, you call them lists. Everything's lists. So you just give a bunch of values of different types, comma separated. So that's a way under one label, under one variable, you can store multiple values if you want. Sometimes you just store a single value, or you can store multiple values all under one name.
So like, how do you get a specific of the three?
What's that?
How do I decide which of those three to print?
Okay, so if I print sphere name, it's going to print all three of them. Right, and I may just want to print the second one or the first one. Okay, if I want to grab just one of the values out of this list, if I say, no, I don't want to grab, if I just use sphere name, it's going to go back and grab the whole list. If I just want to grab the first list, I do open close parentheses, and I give it the index, what's called the index of the value I want. Okay. So sphere name open. So if it sees a variable with open close brackets right behind it, it says, "Oh, I see open close brackets. So I see this is a variable. 0 means grab the first item inside the brackets. 1 means grab the second item. 2 means grab the third item." There's mathematical reasons for it to do it that way, not logical reasons. Okay. So that's how it grabs the different values in the name. And then this is finally where it comes to a head. Everything comes together. So you yourself can experiment with this if you haven't been coded. So if you want to kind of understand lists, just play with list code a little bit with this code.
So what do we have to turn in for Tuesday?
So Tuesday you have to turn in a Python version of your Seesaw code. But again, you have to be able to run the code and then run it again and then run it again.
Can you practice running like you can in Mel, the same way you can in Python, to make sure it's working?
Can you
highlight it?
Yes, yes. All that is the same. Yeah. Okay, so let me do this. So I'm going to do print ASDF. I'm going to call it back sphere name just because that makes more sense to me in English. You can call it whatever you want. So I'm going to say, because I'm assuming that this command is outputting the name of the sphere that I'm created. If I run this code and I print sphere name, it's storing 2 strings. Okay, it's a list storing 2 strings. Ignore these U's. I don't know why. I think it means Unicode. You can ignore that. It's storing the string psphere1 and the string polysphere1. Okay. If I want to move it, I can either say move the selected object, or right here, if I say move sphere name 0, it will move whatever name it's stored in sphere name, it's going to move that. So if I run this code, it created that sphere and moved it. Now it's going to create a new sphere that's called psphere2, and it's going to move psphere2 because psphere2 is what's stored in that value.
So the plus to using variables is that each time that you run the code, it won't error because Maya's already put it in.
Yeah, because it's storing, when it runs the command, it says, oh, I just ran this command again. It created a new sphere. It called that sphere polysphere2, and it outputs the name polysphere2, stores that new name under sphere name, and then that new name, the sphere with the new name, it's the one that gets moved.
Is there a comma under your cursor? Like,
oh yeah, there's a comma. Yep. So what I want you to do, that's why you're doing this as an assignment, because if I just sit here and explain it, it's like, okay, that's, now it's starting to get a little fuzzy. Or at least it did for me, maybe not. If it makes a bunch of sense, then I feel good. But this is why I want you to practice, and then Joe will go over it again, but hopefully this will be much clearer. This is what you need to make clear. What's this variable thing he was talking about? How is it working? Why does using variables make you be able to repeat this, and so on and so forth? That's what you need to work on between now and Tuesday, to have that seesaw that's created in Python that uses variables that I can run the code multiple times and it correctly creates the same seesaw multiple times without like, again, you don't want to create a seesaw and it moves it over, and then you create a new seesaw and then it moves the old one over. You want to be able to create a seesaw and it moves that one over. Now it creates a new seesaw and moves the new seesaw over instead of the old one.
That has to be done by Tuesday.
It has to be done by Tuesday.
It has to move the other one over. You create it.
Or it just has to create, like I say, if you say, if my seesaw is a board with handles and I group those, and it creates a sphere and it moves the board with handles up. And then when I run the code again, it creates a new sphere, it creates a new board with handles, but sometimes it will move the old board with handles up instead of the new one up. You don't want that to happen. It needs to correctly create the seesaw every single time.
But you have to set up a code that moves the other one?
No, that move. Well, inevitably your code is probably moving parts and pieces around, right? Of the seesaw. So you want it to correctly move those parts and pieces around the first time. So it creates your seesaw, moves all the pieces in the right position.
And you grab that one, move it, and then you do it again?
Yes. So you can grab that one, move it out of the way.
I thought you were saying create it, and then there's like a code that moves
No,
that
no, no,
one and
sorry,
makes
yeah,
a new
yeah.
one. I'm like, I don't.
Yeah.
How do I do that?
You can manually move it out of the way.
Okay.
Then create it, and it moves the new parts and pieces around correctly. Instead of, because sometimes you'll manually move that first one, you'll rerun the code, and it moves those first ones instead of the new ones. Variables help you be able to move the new ones. Yeah. Good. No, that's good. Good clarification.
So just in that example, so what is the R equals true? Like, what is that actually accomplishing for that? Yeah.
R means, the R option means if this is true, if this is, since you're turning this option on, move it relative to where it currently is at.
Okay.
Move it that much instead of moving it to that exact position in world space.
Okay.
It just says, oh, if you're over here, move it up 4 here. Don't move it to 040.
Okay.
You have to put MC polysphere.
Yes, because any of these commands that are spit out in Mel, they only exist inside of this MC module.
Okay.
So if it's later on you'll learn Python commands that are just belong to Python. You don't have to use MC for those. Right now you're just worried about using those, and learning what variables are.
And it's MC
Okay.
only because he named it MC. So you can name it whatever you want.
Oh, yeah. Sorry, and by the way, I ran this the very first time, and then it remembered it. It's a good habit to run it every time. But yeah, if I called it MC as Bob, I'd have to say Bob. MC is just something I made up.
Yeah.
Yeah. Other questions? Yeah. And again, you're freely. This is all recorded.
My question is, if it remembers everything and you told it something that you don't want it to remember, how can you make it forget that? Clear it, clear out data.
Sorry, what was that?
Can you clear out data that it remembers so you can start over?
No. Not for intents and purposes right now. No, once you assign it, it'll just remember until you overwrite it. You can overwrite it with a blank. You might be able to just, you can close by and reopen it. That'll forget it. But yeah, for general, yeah, that's the way it works. For now, yeah.
If I create an object like a polysphere, is there a way to go back and get its coordinates or its height?
Yes, because there's a mel command. I think that's get attributes. And there's an equivalent get attribute. In the get attribute command, you give it the name of the object and the name of the attribute you want it to grab. So for that, you have to look in. Oops. Yeah, for that you have to look in the attribute editor to know what the name of the attributes are. Other questions? Yeah.
Can we turn this in? It's going to be a text file too.
Yes, turn it as a text file. I'll have Maya, so I'll be able to run Maya. Yeah. And Joe, can you double check that that's on the?
Yeah.
Is that all? Okay. Learning Suite should tell you. If you can't remember, you can email me too. But yeah, look on Learning Suite.
Is it like? Is there a description of the assignment online?
Yes. Go to the Learning Suite, click on the assignment name, should have the explanation.
Okay.
Yep.
Thanks.
Yeah, and Joe's going to double check that it's all up to date.
So our assignment would be to end up exactly the same, or could we?
And you can update again, it's figure this out once you're understanding it. If you're understanding it, great. Already start updating your Seesaw. If you're not already updating your Seesaw for now, if you're just trying to figure out what in the world does all this mean, don't feel bad that you're not making it some cool Seesaw yet, because this is first. Then you can make it something cool. You have to be able to understand what's variables, what's a list, what's all this stuff. And it's going to require you asking questions and going
Being
through the
able to understand how, because I feel like I'm gonna get stuck converting most of the time from Mel to Python. So if we could just remake our Seesaw in Python,
Absolutely.
that'd be cool.
Save what you had before. If you want to say, okay, that was cool, I'll use it later, you can just save it and just do a simpler and now. Absolutely. Start with something very basic, get that one, then you can apply it back. Or if you think the old one's stupid, make a different one that's cool. Yeah, for sure. Right now, eventually, it's gonna need to be a more kind of cooler thing that you're building. For now, I just want to see that you built something that you understand variables. Will I know for sure that you understand variables? I can't know for sure. You just have to make sure for yourself, because this is going to build up later. Variables, you'll use those, again, that's another thing you'll use for the rest of your life in coding. But it's so integral into everything computer animation related. Anytime you touch code or whatever, that it's totally worth getting to know and becoming familiar with. Other questions? And please, if you don't have questions, take off. You don't have to stick around. Okay.
We're just modeling it right now. Are we animated at some point? Or are we supposed to be animated?
It doesn't have to be animated. You can figure out the animation stuff. We're going to show how to animate, I think, next Thursday. Joe will go over expressions. Joe, you can put on the assignment description. Oh, sorry. You can put on the assignment description. If they're still just trying to understand the principles, they can keep the Seesaw pretty simple. It doesn't have to be exactly the one that they're trying to implement out.